Hello, good day. Welcome back. We are on embedded system and we are on learning about ARM Cortex M4 microcontroller programming. We are on day 6. I hope you are getting a lot out of this series from the beginning until day 5, and I'm sure you are revising and you are getting yourself familiarized with all the concepts being taught to you. If not, please go back and revise and get yourself familiar, so it would help you when I move with the further session, so you would be able to follow much closer. Today is day 6, and let's get into what day 6 unfolds for us. Today we're going to learn about GPIO, the introduction to GPIO. What is GPIO? Today's sections you will get to learn about GPIO, what is it, and where you use GPIOs and what is its purpose, etc. And what is a pull-up and a pull-down resistor, where is it widely used, and what is a push-pull and an open drain, what is that about, and then you will learn a lot about GPIO registers, because embedded programming is all about programming with registers, and that includes GPIO registers. So you got to learn and master this. Even if you have to by God all of this and keep everything in memory, then that's well and good. The senior engineers does that. So this is just a good practice for you. So please pay more focused attention. If not, go back to your data sheet and you can also refer back to there. Before jumping into today's session, I would like to give a small introduction about who we are. I represent Day2. It's a startup company started by Anbukarasu brothers, my brother Alex and myself Arul. We started in 2023. Both of us gathered over 20 years experience in the industry, and we would really like to share our experience and our knowledge to you all there, so you can also build and be a very professional engineer in the future. And our mission is to convey at least to 100,000 students out there and future upcoming professionals through online courses. And the good thing about our service is that you can study at your own pace, at your own time, wherever you are, and that is really good. A little bit about me. I am Arul Prakash Anbukarasu. You can call me as Arul or APA, as popularly as I would like to be. I have 20 plus years of experience in working in various industries in Australia. I came to Australia back in 2003 and did my master's degree in majoring in embedded systems, VLSI, and project management. And since then, I've been working under some major industries, mainly concentrating on renewable energy sector that's dealt with solar and wind energy, power systems, lead acid batteries, and network embedded systems that's linked to ATMs, teller cash registers, point of sales, POS, banking automation systems, and smart parking operations. I got a little announcement to make. I have categorized into two different sections: YouTube viewers and internship professionals, as you can read. What is that about? YouTube viewers, you are eligible to get a free e-certificate if you have attended and watched at least 28 classes out of the series. Due to regulations from YouTube, all the videos has to be removed after 2 or 3 days, so you can't go back to revise if you miss on day 1 or day 2, and that's the drawback. So I personally recommend you and advise you to sign up for our internship, where that will acquire you to get a internship certificate. Yes, that is worth a lot in the industry, as you would realize when you get into that interview or after landing into that first job. When the senior engineers assess you, you will sit right on top because you already got through this 30 days of learning, and this counts a lot. It's not only that, you can get into our learning management system portal and you can get access to everyday session, and that also counts as your attendance for the certificate. Not only that, you also get unlimited access to the course contents and to our course videos. You can stop, you can pause, you can come back and rewatch it again as many number of times as you would like. And if you get stuck anywhere, you can contact our friendly backend support and they would be able to assist you to move you through the course. So now let's get in. And these are all the materials required for you to get your hands on, so you can get a lot out of this course. So please contact Pantech Solutions. As you can see there, they are a very big manufacturing company and they would be able to acquire you to get all of this to you, because once you start to practice on your own, that worth a lot. Instead of just listening to me or reading or watching my videos back, you can get only so much percentage, like about say 15%. Whereas if you have your hardware in your hand and if you already downloaded the IDE and you can set up a lab environment at home, that indulges you to get more out of this course, because you will be pressing buttons, pushing this input or sending that output, so you will get to learn different aspects and that stays with you for a long time. And I would say something like 80% if you have the hardware and if you play around it, then you will learn, because you will be really job ready. So once you are in the job, they don't have to train you much because you already learned through these 30 days and you would know what to do. If a senior engineer comes and tell you, you would be able to even give them a good response, and believe you me, take my word, they would be really stunned, because I went through that and I experienced as well, so as my brother. So you would hear this from us a lot. So please contact Pantech Solutions to acquire that. Are you excited to get in to see what's unfolding to us today? Let's get started. First, we start with the introduction to GPIO. What is a GPIO? GPIO abbreviates to General Purpose Input and Output. It is customizable. It is also controlled by software. For example, in this picture, it is an 8051 microcontroller. As you can see, it has ports written all over it. Port 0, port 1, port 2 and port 3. Ports are nothing but they are your GPIOs. Whereas I said the input and output pins, so you can configure these ports as either as an input or an output, and these can be customizable. That's what it means. So each and every pin can be customized whether to use it as an input or an output, and that can be controlled by the software. The code that you're going to write, that will help you to determine whether that pin is used for an input or an output. So for example, when I say, or when someone points out P3.2, what does that mean? It's on a port 3 and point 2 is the second pin on port 2. So 8051 it is a 40 pin IC, a microcontroller, and as you can see, it has 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 4. So it has 32 ports in GPIO. Likewise, in every microcontroller, the GPIO varies. So you have to stick to your manufacturer and download the data sheet and go through yourself, and so you would be more familiar with GPIO. But for us, with this series, Cortex M4 GPIO, there is 16 GPIOs in this course, so you will get to learn ins and outs of the GPIO. Now let's learn about what these small circuits represent. So when a GPIO output is connected to a current limiting resistor and that connects to the LED, if the LED is connected directly to the ground, that means this circuit is considered as an active high, meaning the output is dragging along with the current limiting resistors, so that would allow plenty of voltage in there, so the LED will be brighter. So if the LED is connected to the ground, then that's active high. Whereas if the LED is connected to the VCC, and we are talking in terms of GPIOs, if the GPIO is connected to the anode of it, then it's called LED active low. Also take this example. If a button, if it is connected, or a switch, if it is connected to the ground, then it is considered as an active low because it's open, no voltage flows through, and the output GPIO input, what it gets, it's the VCC value. Whereas the other way, if the switch can be called as an active high if that is connected to VCC, because when it is connected, the same voltage will go into as the input. So this is the difference between the active low and active high in terms of LED and switch, and this is what we're going to see in the next session about controlling these. Moving on with the GPIO, as I said earlier, 8051 chip got 8 IO pins. On those 40 pin IC you got 32 pins, but this is 8051 and the previous one I showed was a different one. In the LPC 2048 it's 32 IO pins. It's from NXP, from a company called NXP Semiconductors, and this is the one we are learning in this whole course, STM32 Cortex M4, and it has 16 IO pins, and you will get to learn about what they're all shortly. So what is a pull-up and a pull-down resistor? A pull-up resistor is connected to the power supply, so it can pull the floating pin to logic level high. That's what it is. A resistor that is connected to the VCC, when you can lift and pull to the high level to as close as to logic high, then that's considered as a pull-up resistor. Whereas a pull-down resistor connects a floating pin to the ground, that makes us logic 0. If a resistor that's connected directly to the ground in terms of this circuit, then this is considered as a pull-down resistor because it's trying to get you to the logic level 0. That's the difference. Pull-up connected to VCC, pull-down connected to ground. That's the difference. What is a push-pull configuration? When we talk about push-pull configuration, there is two types of output type configuration. One is push-pull and the other is open drain. So first let's learn about push-pull, then we'll go into open drain. Push-pull is the most common output configuration used. Push-pull out can drive two output levels. What are they? One is pull to ground, that is pull or sink current from the load, pull or sink current from the load, and the other is push to power supply voltage, push or source current to the load. So it has two phases in push-pull. There is a push phase and there is a pull phase. The push-pull output can be implemented using a pair of switches using CMOS technologies. In practical, the implementation in an integrated circuit involves the use of transistors, use of PMOS and NMOS. In a push phase, you give the internal signal, and being VDD is connected to the PMOS will be in active state, and NMOS is connected to the ground. If you know CMOS theory, then you would follow me with this. NMOS will be active low, in other words it will be off, so the VDD voltage will go out to the output pin straight away, whatever the VDD is. So that's the push, so it's pushing down via the drain and it's going out. Whereas in pull phase, the VDD, it is the reverse of push phase. The output drain that's pushing down because the NMOS is active in the off state, so you get 0 voltage, so that's the pull phase. Let's get to understand a bit more about push-pull explanation. Push phase, when the internal signal connected to the gates of the transistor, refer to this picture, is to set allow logic 0. The PMOS transistor, as I explained, is activated and the current flows through it from the VDD to the output pin, and the NMOS transistor is inactive, open, so therefore there is no conductivity on NMOS. When the internal signal is connected to the gates of the transistor, is set to a high logic level 1. If you send 0, then PMOS is active. If you send 1 as the internal input signal, then the NMOS gets activated, so the PMOS, that means it's closed, and the current will start to flow through it from the output pin to the ground, and PMOS will be inactive and open. No conduction happens in PMOS. So that's the logic. In a logic 0, PMOS active, NMOS inactive. Logic 1, PMOS inactive, NMOS active. That's a push-pull. Push-pull, either or. So now let's move on to the second output type configuration. What is it? It's called open drain configuration. In open drain configuration, the logic behind this pin can drive it only to either ground logic 0, or the other possible state is high impedance. The advantages of this configuration is the ability to directly drive a load, the ability to switch external sources that may have higher or lower voltages as close to VDD, and has multiple sensors connected in a multiple configuration. So the one difference in open drain is it doesn't have a PMOS, so it has only NMOS, and if it wants to be connected as close to VDD, then you need an internal or external pull-up resistor to be more operative as it is. So if you take 8051, all the GPIO pins are configured with open drain because it's just how they're manufactured, and that's how they program on that. So open drain outputs are most widely used in communication interfaces where multiple devices share the same bus line. Example, in I2C, one master will be connected to a lot of slaves through two-wire line, the SDI and SCL, which you will learn later stages. And also it also called as a one-wire, etc. When all the output devices are connected to the line or in high impedance state, then the line is driven to a default logic level by a pull-up. As I said earlier, high impedance state is when a device is in a fluctuating mode between 0 and 1, 0 and 1, 0 and 1. So it doesn't know which state, so that refers to a high impedance state. And to pull up to close to VDD, you need a pull-up resistor. So that's what it explained in this line. Now let's move on to GPIO modes. GPIO modes is configured through an enable line. Every enable line, it acts like a peripheral clock, if you like. So first, if you want to activate the port, you need to enable that line first. Then it depends on the input buffer and the output power. The pin gets the value either written to it or read from the pin. So first let's find out how the output mode is configured when enable line is 0. So take this for example. When the enable line is 0, it comes through and hits the inverter. As you know, it inverts the value. So you get 1 here, and the output buffer writes as 1. So this pin, if you put a multimeter in there and find out, then there it will be high, logic 1. And here, because the 1 is coming out, so the input buffer won't be active, because the input buffer is directly connected to the input buffer enable line. So what is enable line coming? 0. So the input buffer has come as 0. So the output buffer having an inverter that inverts 0 to 1. So that's the output mode. That's how it's configured. Whereas the input mode is configured when the enable line is 1. So you have to set enable as 1 to read the input buffer as 1, because 0 doesn't make any sense. So 0 is no value. So output buffer goes to a idle state or non-conducting state, or whatever way you call it. The input buffer gets activated, and that's what you get in the pin read. This is about the output mode and the input mode configuration with enable line 0 and enable line 1. Now showing how this is linked with the help of transistors, how the input buffer is linked directly with the circuit below. So this is how it's going to transfer. So the PMOS is connected to the VCC, and the pin is read on the internal connections that's connected to the gate. So when a VCC is on, when there is enable line 0, it inverts and PMOS gets activated. So whatever you get there, that will go out. So the output is set. If the enable is 1, if the enable line is 1, then PMOS goes to sleep or inactive mode. NMOS is wide awake. So therefore you get a logic 0. So that's how the transistors are linked. Further getting into the logic analysis, writing 1 to the output pin will invert to 0, and because that sends to the output buffer, the PMOS, when it gets 1, then it's activated, then NMOS, if it's 0, it's deactivated, then it gets to the ground. So that's how it's explained with the link of 1 comes through and it inverts. So 0 goes to the NMOS. NMOS is in off state, and whatever the PMOS is high, so the output pin gets the value as 1. How to read 1 from the input pin? In this example, the pin, the internal pin or the enable pin, if you like, is sending a 1, and that sends a 0. So again, that inverts to PMOS. PMOS gets 1, so therefore whatever the value in PMOS, that gets activated and the output is collected as 1. So this is how the pin gets read. And NMOS, it's in off state, which means 0, and it doesn't get any value. So this is how a reading 1 to input pin works. We talked earlier a little bit about the high impedance state. What is that is when a pin is not connected to either a ground or to VCC. If it is not connected and if it is in unknown state, then it will fluctuate, and that makes a leakage current goes higher. And when that goes higher, then there is more power consumption. To avoid that, you could either connect to the ground, or you can connect to a pull-up resistor and connect to the VCC. Try to make either 0 state or 1 state. So this is about the leakage current. That's what we talked about earlier. By default, all the GPIOs comes with the input mode. So you need to change, if you want to change as output, you need to tell the program, in the program, you need to tell that's going to configure for output. What is high impedance? So as we were saying earlier, if the input pin is connected as 1, PMOS gets activated, and whatever value it's there, so PMOS will be in operation. NMOS will be off, so NMOS won't be in operation. Whereas if the pin is connected from the ground, it is connected to the ground, so NMOS only works when there is a 0. Means if it gets only 0 value, then it gets active, and what it gets to the ground. So this can only give a 0 or a what is called a floating value. That's what we measure as high impedance, because it's in a fluctuating mode between 0 and trying close to the VCC value. So that's the difference. VCC, when it is connected, then VCC PMOS is active, so therefore you get to the logic 1 or 0 and 1, and here it's connected to the ground, the pin, so you get either 0 or high impedance. And there is no leakage current, therefore less power consumption because it's grounded. Because earlier here we learned about if it is left open, you get into the high impedance state, therefore there is plenty of leakage current, and that consumes a lot of power. Whereas in this case it's grounded, so therefore no leakage current, therefore no power consumption at all. What is an open drain? So considering this as an example, the open drain, when you send a 0, it inverts to 1, and the NMOS it gets as 1, and the NMOS the read value, because NMOS is off, and it sends as 0. So that's how it works. Sending 1 via the gate, and NMOS reads as 0, and it goes to the pin, and it doesn't know whether it's a 1 or a 0, so therefore it's in a floating state. So these two are the outputs that you can get from open drain configuration, either ground or either floating. Either ground or floating. So those two are the output configuration types from open drain, ground and floating. For push pull, you get either 1 or 0, those two states. For open drain, it's ground and floating. How this is looked with an LED with an open drain explanation. So if you want to have the LED to be well lit, open drain with pull-up resistor. If you have a pull-up resistor, then what it does is, even though there is no PMOS, so the NMOS will try to pull up close to the VCC. Therefore, the voltage will be allowed into the LED, so that makes the LED come on, and it will be as bright as your eyes can see. So that's the purpose of the pull-up resistor here. Even though it's an open drain, but if you put a pull-up resistor, that does its job to keep the LED on. Whereas if you want to keep the LED in an off state, then what you have to do is you need to send an input signal or enable signal 0 that inverts 1. That means NMOS is active, so therefore nothing gets in and no voltage goes through, so the LED is in off state. So that's the difference. Here the pull-up works with 1 coming through and sends through the voltage, makes it the LED to glow. Here you're receiving 0, so the NMOS gets activated and it turns off, so nothing comes out of drain and no voltage goes through, and the LED goes to off state. So that's the explanation with LED. As I said earlier, the open drain can be explained good with the I2C, inter-integrated circuit. It is one of the communication protocol where I said multiple lines share the same bus lines, HCL. So there are multiple slaves connected on the same line. That's what open drain is good for, and much preferred solution for I2C. With help of pull-up resistors, it will get this value as closest to the VCC. That's pull-up resistors. By default configuration for output mode, it's push-pull. Is a default configuration because the output can be either 0 or 1, and that's where you use mostly the push-pull. Now we're going to see push-pull with LED as an example. We just saw open drain. Now how the push-pull will be effective with LED as an example. Now for instance, to turn on the LED, the pin has to be connected with the current limiting resistor. So when you send a 1, logic 1, PMOS gets activated. So if it is a 5 volt, it comes through as a 5 volt. And this current limiting resistor tries to protect the LED not to burn out, because sometimes the LED maybe go a bit above the VDD. So this resistor limits it and allows the required voltage so the LED can come on and stay on. So that's what it's explained. The current limiting resistor, 1 you send through and the PMOS gets active, so it's coming through. Say if it is 5 volts, it's 5 volts, and this resistor will limit and only allow what it's required for LED to be on. Whereas to turn off LED using push-pull, it's the reverse. You need to send 0, and once it inverts, when it is 1, then NMOS gets active. There is no power supply, voltage supply coming through, so none will come through this. Only 0 comes through this drain, so therefore the LED will be in the off state. So this is the difference of the two, open drain and push-pull. Okay, I think you must be a bit restless by now, so I'll give you 5 minutes break. So please go and enjoy that break, and I'll see you again in 5 minutes time. Catch you then.